Good morning, Algebra 2 students. Welcome back to another session of Vandenberg Virtual Math. I think this is lesson number 11, at least by my count. And I hope you're all doing okay. Let's see here. This whole Zoom stuff stresses me out. I don't like those, whatever. Anyway, today's title is, sorry about that little aside there. We're going to continue solving exponential equations. So it's called, we're skipping level 2, so this is exponential equations. And I'm going to use the abbreviation again there. Level 3. And the technique we're going to use is the same as we used in level 1. We're going to solve them using a common base. I skipped level 2 because I can't do every darn worksheet on this website. And also it was not as necessary. It was kind of a ridiculous. The numbers were all really, really high with oddball like bases and stuff. So that was not important. So we're skipping right to level 3. Similar, but we're going to use slightly more complicated bases on these. And you'll see example number 1. 1/49. There you see we have a fraction raised to the 6x minus 27 power. So the fraction is the base, unfortunately. And that equals 7 to the 3x squared plus 9x. That's an x squared there. Okay. Well, I'm hoping you recognize that the connection there between 7 and 49. But we have to remember what to do with the fractional exponents. I wish I could call on somebody right now. But you do remember that fractional exponents. First, I'm going to write it as a power of 7. 49 is 7 squared. So at least we're getting closer to a common base now. And the right-hand side, I don't have to mess with the base. But if you'll recall, when there's an exponent in the denominator and it's positive, if you bring it up to the numerator, it's negative. Negative exponents just mean fractions. So now I can rewrite it with the same base, but I'll use the negative exponent. 7 to the negative 2 power raised to the 6x minus 27. And that's going to equal the same expression on the right-hand side. Let's distribute that negative 2. So now we have 7 to the negative 12x plus 54. And that's equals 7 to the 3x squared plus 9x. Now that we have the same bases, we can make the exponents equal to each other. And as you can see, in this case, we're going to have a quadratic equation. I checked the problems on the worksheet, and I'm pretty positive, oops, that's a 3x squared plus 9x. Pretty sure that all of them are the factorable kind. Anyway, let's get everything on one side. So I'm going to add 12x, subtract 54, add 12x, subtract 54. And now I've got 0 is equal to 3x squared plus 21x minus 54. And at that point, I'm running out of room. So I'm going to take a little sip of tea here, let you guys catch up, and then I'm going to clear the whiteboard. There we go. And now I'm at this point here, 0 is equal to 3x squared plus 21x minus 54. Well, This looks harder than it is with the number in front of the x squares. So you should notice that there is a GCF here. 54, 21, and 3 can all be divided by 3. So I'll factor out the 3 first, leaving x squared plus 7x minus 18. And that is not too bad to factor. I'll leave the 3 outside my 2 parentheses, xx. Two numbers that add up to 7 and multiply to equal negative 18 would be positive 9 and negative 2. And we use the zero product property again. X plus 9 equals 0, or x minus 2 equals 0. So x equals negative 9, or x equals positive 2. There it is, problem number 1. We'll do a couple more just to see slightly different type combinations of bases. I think the next one we have to rewrite both of the bases. So I'm going to clear the whiteboard. There we go. Problem number 2. 1/2 raised to the 3x squared plus 15x is equal to 1/4 raised to the, negative 18x. Is that a 15? Dang it, it's 15. Negative, excuse me, you guys. I messed up there a little bit. That should be a 15. Negative 15x minus 81. 1/2 and 1/4, they're both going to be negative exponents. 1/2 is 2 to the first, 4 is 2 squared. So I'm going to rewrite those bases as 2 to the negative 1 to the 3x squared plus 15x is equal to 2 to the negative 2 raised to the negative 15x minus 80. Now we distribute the exponents, and they have the same base, so I'm just going to skip that step if that's okay with you guys. I'm just distributing the exponent on the base. So I have negative 3x squared minus 15x is equal to 30x positive plus 162. Let's get everything on the left side here, which is going to make everything, actually, I don't want a negative in front of the x squared. Let's put it on the right-hand side. We could have done it, but we would have had to factor out a negative number. Easier if I just add. So add 3x squared, add 15x. And my new equation is, I can write a little bit more concisely here. 0 is equal to 3x squared plus 45x plus 162. Okay. Factoring out of 3, we have 0 is equal to 3 parentheses x squared plus 15x plus, what's 162 divided by 3? Shoot, I didn't say this one first ahead of time. It's going to be 54. Then I factor it. 3 parentheses, 2 parentheses, Two numbers which add up to 15 and multiply to 54 are 9 and 6. X plus 9, x plus 6. Using the zero product property, x plus 9 equals 0, or x, so that's supposed to be a 6. X plus 6 equals 0. So x equals negative 9, x equals negative 6. I think that should do it. There's one more example I was going to do, but it's pretty much the same as the first two. And I hope that's good. Again, if you need help with this assignment, I'll have a Zoom session for 7th period tomorrow and 4th period today. Today's Wednesday. And first period, a Zoom session is on Monday. Now, you can always come to one of the other classes if you can't make the one scheduled for your own period. So anyway, hope you guys are having a good week, and I'll talk to you soon. Take care. Vandenberg Virtual Math signing off.